You don't have this portion, but I do want to talk about it because there's some important things happening here. So this is part of a scatter plot, and you can see here's hour 4. It's 25 degrees. Hour 10 after, not hour 10 after noon. So if it is noon, I guess it is 10. And it is 8 degrees. So how would you characterize the temperature change from here to here? It would go up or down? Down.
Yeah.
But without other information, could it have gone like up a little bit, then down really quick, or like over then down real sharp? So in general, we're saying from 4 to 10, it went down by 17 degrees.
Yeah.
Right? So that's how much it fell. Everybody's seen that going down aspect? So our rate of change is decreasing. Can we tell how fast it's decreasing?
Not quite.
Well, with this information, we can do something.
4 hours.
We could say 17 over 6, right? It's going down 17 degrees over 6 hours. So about how much in each hour?
About 2.9.
Yeah, close to 3. I just put that squiggle equal, right? Close to 3. And is that going up 3 or down 3?
Down.
Down 3 degrees per hour, roughly, right? Now, this per 1 hour, it's a special rate. So this is an average rate of change from these 2 points. But when we go per one thing, what's that rate called? It's a special name.
Rate of change?
It is a rate of change, but so is this. This is also a rate of change, but per 1 hour. It is, the rate of change is slope. I'm looking for this word.
Unit rate.
It's a unit rate. So like price per pound, feet per second. Why would it be nice to have per one thing versus 17/6? 17/6 the same ratio. Why is it nice to have it per 1 hour instead of per 6 hours, Ava? It can be a constant proportionality, but you have a rate of change. Which one's easier to wrap your head around? On the expressway today, I went 210 miles per 3 hours or 70 miles per hour.
70 miles.
Yeah, it's easier to compare things as a unit rate, right? They're really useful. Or price per pound of apples. Like you got to do that at Aldi because Aldi apples only come in bags, right? It'll be like a 3-pound bag for $3.99. You got to figure out a price per pound. You go to Fresh Time, it's already priced per pound, right? And then you just pick apples. But if you want to compare apples to apples, pun intended, you need them in the same unit rate. Okay? Price per pound.
That's a fun game.
Then Trader Joe's does this weird thing, price per apple. What is that? A huge apple? Small apple? I don't know, man. I'd just be picking out the biggest ones if they did that.
No, I actually...
We're going to look at a scatter plot that has some more data on it here. And I want you to turn to your table or table partner and talk about things that you notice and things that you wonder.
You know, it started out about...
Whoops, wrong page. Let's talk about these notices and wonders. So I think the notices are easy. Let's just get a couple. Who'd like to give us a notice? Sean?
That's generally trending downwards.
So you're seeing like from start to finish, you can see general down is what you're saying. Okay. What's something else we notice? Vinny?
In some spots, there's a little, like, I don't know how to explain it. Like, there's a little jump up at the end.
Oh, so Vinny's saying in some spots there's a little increase.
Yeah.
Okay.
It just keeps the trend down.
So what I was noticing is I could kind of like generally trace this almost in like 3 little segments of up and down. You see that? Just a general. That's not like very pretty or anything. What's a wonder anybody has? What are some wonders?
Why did it go up at the end?
Yeah, why did it go up at the end? So nighttime's not a popular time to get warmer, right?
No, like, unless it's Florida. Sometimes it gets warm at night.
Sometimes it does here, but not often. Okay? And also, I mean, this makes sense. After 4 p.m. in Michigan, at least in the winter, right? It starts getting darker, cool off.
Sometimes.
Warming up here makes sense. So, yeah, this is my wonder. I was wondering if there's a way we can, like, use some relatively simple numbers to explain what's happening. Because if I just said for the temperature from here to here, would this be representative of the situation? Wouldn't be great. Like, it wouldn't be a big picture. You could get a number, but it wouldn't be a big picture. So I'm wondering if I can break this thing down a little bit. We'll see. But what I want to show you is this. This first part is asking, how does it break down hour by hour? So that would be like 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. Okay? Are you guys seeing that question there? So help me out. From 4 to 5, how does it change?
It goes up.
It goes down 2, right? Down 2.
Looking at the wrong.
5 to 6. Down 6.
Yeah, 6 to
6 to 7, down 2. 7 to 8, down 4.
Yeah,
8 to 9. Doesn't change.
9 to 10.
9 to 10.
Down
3.
1.5. No, 3.
So as I look at these changes by hour, these rates of change from each individual interval of hours, is it consistent at all?
Absolutely not.
No, and if I was like, hey, Kai, let me tell you about this weather. From here to here, did this. From here to here, did this. And from here to here, did this. You'd be like, this is not a good conversation. Also, that's like a lot of numbers. How am I supposed to put that together as generally what's happening?
It's not going to
Well, there is a way. This is a rate of change for each hour. We can find an average rate of change. And we'd be looking from point 4 to 10. Okay? This line right here. Now, all those other points, they're pretty close to that line, eh? Pretty close? Would you say that line is a trend? Yeah. So we can find an average rate of change there, and let's do that. So, how much did the temperature change by? We already saw this one before, right? 17 degrees. Over how long?
6 hours.
6 hours. And that got us like 2.8 something, right?
Yeah.
I said about 3. Now, if I was like, hey, Kai, just in case, I know you want to know this, but between 4 and 10 p.m., the temperature dropped almost 3 degrees per hour. Oh, and this should be negative because it went down 17. So it dropped about 3 degrees per hour. Does that give a pretty good representation about what's happening on this interval right here?
Yep.
Yeah, way better than, girl, let me tell you what happened. From 4 to 10, this, right? So it's not misleading. It's good communication, and it explains the trend. Would you agree? So this is called the average rate of change, a.k.a. slope.
Yeah.
It is the slope. Down 17, right 6. Well, you could write slope-intercept form for that line, but we're just talking about how it changed, which would be rise over run. It's also why, who can tell me why it's negative? Why is this a negative average rate of change? Zeph?
Because it's all going downward. Like the line, the
Yeah.
change is negative.
The change is negative degrees. It's going down. It's yelling timber. Okay. You and your table, you're going to do problems 1 and 2 here. Now, what I'm going to ask you is, if it's asking for these intervals where you need to pull off data, what do you think is going to be the better representation, the table or the graph to pull off data? We got some graph people, okay? I got some table people.
I would say table.
All right, as you maybe try the thing you're thinking, and
I would
then
say table.
try the other and compare the two. But I need you to answer problems 1 and 2 here, please. Riley, between noon and 1, how did the temperature change? Went 1 degree, and I'm going to put like a up, but it got warmer. Noon to 1 is warming up a little bit. Okay, what about noon and 4? Ari, what happened noon to 4?
It was about 1.5 degrees an hour.
So noon to 4. Well, how much did it go up by? 7?
Yeah, I got 7.
I said 6. Yeah, I miscounted.
18 to 25?
It is 7. Yeah, went up.
I said 7.
Okay, how many hours?
I miscounted. Went up by 7 and what?
So, yep, which would be 1 3/4 degree per hour,
I just did that.
right? You go with that, Ari? Or 1.75 per hour. So almost, it's going up, right? And here's where that is in the graph, friends. Up, up. You could probably done that in like 1 jump instead of 2, right? 1 degree, almost 2 degrees. But do you see those 2 little segments I just drew?
Yeah.
Up, up, kind of. Or actually more like up, up. But then what's happening after that? It goes down. Well, before, when we found just this portion that I'm about to draw in red, right? It went down like
11 degrees.
2.8 degrees per hour, right? The red, what I did in the red.
Oh, yeah.
But this case has two different reference points, which I'm going to do in light blue. Now we're looking from here to here. What does that take out of the factor? It takes out those increase hours, right?
Yeah.
Okay. Kind of, right? If you're going from here to here. But that rate of change that we got for that segment from noon, it went down how much total? From noon to midnight. Went down 11?
Yeah.
Over how many hours?
12.
So a little less than 1 per hour. What is it, 0.9?
Something.
0.7?
It's not.
Oh no, 0.9 would be 9/10.
Yeah, but
Right?
something close.
So 11 12 has to be close to 0.9, right?
0.91.
Yeah, okay. So what's interesting is if I go from that on that blue line, that shows a rate of change of about 1 degree down per hour. Is 1 degree down per hour a real good representation of my situation?
Not really.
Not really.
Because it
The
says-
better representation would be chunking it off into what's happening a little bit. But here, this is an instance where math that is good and correct can be misleading. That happens in the real world all the time, by the way. Right? Watch this. Watch this. You ready? Sean, what toothpaste do you use?
Crust.
Hey, students pulled in Mr. Max math class, 100% of students pulled choose Crest. Is that good math? I mean, kind of one is 100%.
Yeah. I mean, it's.
So it can't just.
That's basically how.
I don't know if you ever heard anybody talk about how math is communication, though, or multiple representations
Like
to
how
get a whole
people-
situation.
Like how
But-
Wendy's commercials say that their
Look
fries
for
are
more.
better than McDonald's.
Yeah, yeah.
That's not
50%. No, it's not.
It's because 4. No, I just made up a number. I don't know. But what I'm saying is, we need more context sometimes. And in this situation, breaking it up into these different chunks, not this last one, but breaking it up into those little chunks of what's happening, tracing the actual situation, would be more representative of the situation, right? Even though it's still not perfect. Start to finish, noon to midnight, not a good representation, although it still is the average rate of change. I'm going to have you guys roll through this with your partner. Same idea. But let's actually take care of number 2 together because I think number 2 is a silly one. Which one grew more quickly from 1900 to 2000? Well, let's look at this. Which one started lower?
California.
Okay, and in 2000, which one started higher?
California.
Do I need to find a rate of change difference to answer that?
No, because it's
No.
obvious.
It started lower, ended higher. Don't even worry about number 2. Focus on number 1 with your table group, please. All right, let's find these rates of change. So, let's look at California first. I'm going to use the blue. From 1970 to 1910, it went from here, or to 2010, sorry, to here. So how much did it go up by? Like 18?
Yeah.
I said 18 because it's even, and let me show you why. 18 over 40 years. I got that to a nice rate by doing this. 18 million over 40 years. I did 18 40ths is 9 20ths, which is 4.5 tenths, which is 0.45 million per year. So I did the even thing so I could do it in my head. Now, you could interpret that instead of 0.45 million as 450,000. That's the same thing. So 450,000 per year increase for California. That's a lot, like a $500,000 per year, boom, 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 every year. Now what color is Texas is kind of reddish. Let's go reddish. So Texas in the same time period went from about 12 to 25. I'm gonna do 12. I'll show you why. So it's an estimate, so it's even. So that's 6/20ths or 3/10. So somewhere around 300,000 or 0.3 million per year, which is about 300,000, somewhere in there, 350,000 per year. And it looks like, if you guessed extending this, right? If you guessed, it looked like, but we know the last 2 years happened. Texas is booming. Cali is not. Interesting times, right? So, in this situation, what does each rate of change mean? It means the average number of people who lived in a state increase per year? Something like that. How much it went up per year? Did it ever go down in this case?
No.
I don't think, even right here, it looked like it thought about it, but then it didn't.
It was just a very low.
Yeah, so it always increased. So our average rate of change being positive said people are moving to California and Texas. Or, actually not that, their populations are increasing, so maybe they're just having a lot of children. Or a combination of the two, right? It's total population. And it's just raw number. Like in context, if the same number were applied to like the whole country of China, would it be as significant?
No, because
300,000 extra people per year in China, is that as significant as 300,000 extra people per year in Texas? Right? It's different, right? So sometimes we might even want more information. Like, what is this in relation to the total population, or like population growth that's normal with most places? But these numbers would give our average rate of change per year for these places. And then again, which one grew more quickly? Cali. It started lower, ended higher, right? Started lower, ended higher. Cool. Let's hit you with that cool down.